Welcome to aminacademy.com. In fluid mechanics, let us discuss about loss of head due to frictional loss in pipes. Here, look at this pipeline through which liquid is flowing. Here, pressure at section 11 is P1, pressure at 2 is P2. Now, frictional loss, this side is friction is this F1. Here, the friction flows like here. Now, we will consider P1 is pressure intensity at 1 at section 1. V1 velocity of flow at section 1. L equal length of pipe between section 1 and 2. Length of pipe between section 1 and 2. Now similarly, P2, V2, P2 it is considered, that is pressure at section 2 and V2 is velocity at 2. Applying Bernoulli's equation, that is P1 section 1 and 2 P1 by rho g plus V1 squared by 2g plus datum Z1 equal P2 by rho g plus V2 squared by 2g plus datum Z2 and friction losses HF. Now here the diameters are equal, that is diameter at section 1 and 2 are equal. Therefore, here V is constant, that is V1 equal V2 because cross-sectional area is same in both section. Therefore, V1 equal to V2. Now applying this condition, we have P1 by rho g plus Z1. Also considered datums are equal, Z1 equal to Z2. Therefore, we will write finally P1 by rho g is equal to P2 by rho g plus HF, head losses. Therefore, we have HF equal P1 by rho g minus P2 by rho g. But here HF is the head loss due to friction and hence intensity of pressure will be reduced in the section of the flow by frictional resistance. Here due to frictional resistance, due to frictional losses, pressure will be reduced. Therefore, F1, friction force F1 equal F dash pi dl, circumference of the pipe into length through the length, into V square. Therefore, wetted area here, that means frictional force is in the wetted area of the pipe, that is pi d L is that area, into here F dash into pi dl into V square. Now the force acting on the fluid, the forces acting on the fluid, are, first one, pressure force. Pressure force, that is equal P1 into cross area of the pipe. The second one, pressure force at section 2. This is pressure force in 1. Pressure force in 2 equal P2 into cross area A. Now here third force is frictional force. Frictional force, that is F1. Therefore, resolving all forces, we are getting P1A minus P2A minus F1 equal to 0. From that we can get it P1 minus P2 into A equal F1, which is further F1 is the friction, F1 is equal F dash into P L V square, P into L into V square. Here, which is equal here F dash pi dl is pressure P into L into V square, P into L pi d L into V square, because here P is the perimeter. That P is here we are applying, that is P is your perimeter. Now therefore we write P1 minus P2 equal F dash P L V squared by A. But from the equation 1, here already we have the equation 1, let it be this 1. From equation 1, P1 minus P2 equal rho G HF. Rho G HF. Therefore, we equating the values P1 minus P2, that is P1 minus P2 equal, that is rho G HF, which is equal F dash perimeter into length into V squared over by A. From that, HF equal F dash by rho G into P by A into L into V square. Here this P by A is the ratio of the perimeter by area. So we now perimeter by area equal wetted perimeter by area for this, that is wetted perimeter is pi d, area is pi d squared, so cut this is pi d squared by 4 here area, therefore which gives 4 over d. Here this p by a, the ratio of p by a is 4 by d for the pipe, therefore we are writing hf equal f dash by rho g into 4 over d into L into V square. Therefore, HF equal F dash by rho G into 4 LV square over D. Now, here putting F dash by rho equal F by 2, where F is a coefficient of friction of pipe, where F is a coefficient of friction, of the pipe, coefficient of friction, therefore it becomes HF now, HF equal 4 F over 2G into LV square by D. Therefore, here we write HF equal 4 FLV squared by D into 2G. This is a friction where then F is known as friction factor. Here F is friction factor. Therefore, this is the expression for frictional loss of fluid flow through pipes. That is 4 of LV squared over D into 2G. We have done. Please subscribe our YouTube channel.